Hello everyone, this is Sridhar Chinta. Today I am going to demonstrate how to use Weka data mining tool to build classification models using decision tree algorithms. To do that, let's first open Weka data mining tool and click on Explorer. Let us first import the data into Weka. Click on Open File, select the dataset, and now the data has been loaded into Weka. The dataset I am using for this analysis is patients who are diagnosed with diabetes and what physiological metrics can be used to classify them as positively and negatively tested for diabetes. There are 8 attributes in this dataset and one class variable. For example, if the type of attributes here taken in the dataset is body mass index, age of the patient, and number of times the patient has been pregnant, etc. This section gives you the summary statistics of each attribute. Here we can also see what is the type of the attribute and number of missing values in the attribute. If there are any missing values in our data, we can use the imputation technique to get rid of that issue. One of the filters which are inbuilt in Weka can help us do that. So let's see which filter is that. Click on choose, select filters, unsupervised, attribute. From the drop down, select replace missing values. So what does this filter do is it will replace all the numerical and nominal attributes with the mean and mode values of the attribute, so that it doesn't affect the mean value of the total column. So since our dataset does not have any missing values, we don't have to perform any imputation on the data. So let's go ahead and build the decision tree. To do that, let's select the decision tree technique, click on choose. Under trees, select J48, and we can give the cross validation as the number of folds, where the technique will divide all the dataset into 10 folds and build the model for each fold and validate them against it. And we can use a percentage split option to divide our dataset into training and test datasets. I'm going to use 75% of the total dataset as training and the rest as test dataset. So click on start. You can see the model has been built. This is a summary of the decision tree, where we can see the 77% is accuracy rate, and which says that 148 instances has been correctly classified and 44 has been incorrectly classified. We can see the number of leaves in the tree and the size of the tree. The size of the tree is nothing but the number of the depth of the tree. The number of leaves is 20. And to visualize the tree, right click on the result set and select visualize tree. To fit the tree to the screen, right click and select fit to screen. Here we can see that the first attribute the model has selected to split the data is plasma value of the patient, and after that it has taken different attributes and determined whether the patient is tested negative or positive for diabetes. Let us look at the confusion matrix of the decision tree. We can see that 29 patients has been misclassified as tested positive for the diabetic even though they were tested negative actually, and 15 patients were wrongfully classified as tested negative though they are actually diabetic patients. So for example, if a diabetic patient is classified as non-diabetic, it can affect the health of the patient in the long run. When analyzing such sensitive healthcare data, we need to be aware of the fact that the cost of false positives is far more adverse and effective than the cost of false negatives. So we need to better predict the patient's diseases by building more accurate models. Thank you for watching this video.